everyone. Hope everyone are safe and healthy. So we continue with the same unit 1. Now we start with personal computer system. So why do we require personal computer system? Personal computers where everyone want their own work to be done at home. So in that case we may use a personal computer. Now every one of you, each student have your own laptops. So why do you require laptops? For practicing, for do so many things you require laptops. So that's what is called as a personal computer. So what is personal computer? A computer system dedicated to a single user. So each one of you have your own laptops or desktops. So then that is what is called as a personal computer. A computer system dedicated to a single user is called as a personal computer. And what are there in this? What you may use it right now? You may only use laptop. Maximum you can use mouse, and you may use all your pen drives, memory card, even you may use a small printer. So these are some of the devices which personal computers may use it. So one is input output device. So if we come to input output devices, which are input output devices, keyboard is one thing which all the personal computers require. One more is mouse. Again keyboard, it's left to what type of personal computer you are purchasing. Maybe desktop computer, or maybe laptops. So as per my knowledge, most of the desktop systems now ruled out. Maximum of them are started using laptops. Why? Because laptops are more portable, means we can carry from home to college and call it back from college to home. Whereas if you buy a desktop system, then it's very difficult for you even for doing any projects, any mini projects or any projects or any work. So that's the reason most of users started using laptops. One type of personal computer, that's laptop. So next, display screen. So again it's left to you. So what amount, what budget you are giving for to buy a laptop. Then again your screen size. So if you want bigger size, then your budget may be high. Not only display screen, again nowadays even high-end personal computers are there, where your laptops are also having a touch screen display, where how you are using your mobiles. So how is your display? It's everything you are using your mobile, just touch screen. Same way even right now most of the laptops with the high end, we have screens with a touch screen, and you may use a small printer. So that's what the thing we may require for our personal computer. And again left to users, what type of software they are using, what type of thing. Again in your personal computers or in your laptops, so from one semester to another semester, it keeps changing the softwares. You can install which softwares you want. Suppose let me take in your first semester, second semester, you may have a C++, and you may require Unix also. So based on your languages, you need a software. So the same way, if you want to run a Java program, then you may use a Java software. So in the same way, as you keep moving on to the next higher semesters, you may require your own softwares. So based on how you are using, that's what the software is. User convenience and responsiveness. So it's left how a user want your based on your convenience, you can use your own laptops, and how much responsiveness you have. So that it's left to you which type of projects you are doing, what is the configuration you want, how much response time you want, how much memory you want. All these before you buying, you would have done some survey. That's what your responsiveness says. Cannot adopt technology developed for large operating systems. Often individuals have sole use of computer and do not need advanced CPU utilization of protection features. So now in personal computers, even nowadays you can see we have so many advanced features if you come for a personal computers. So earlier it was not so high processors and high memory was not used, but right now when you come to right in the market, even the personal computers are also having a high end CPUs, memories, speed up is also very high. That's how it depends upon, as the technology is increasing, our personal computer systems will also have a high end features. Before some 20 years or maybe 20 or 30 years down the line, most of people were having desktops, and very few were having laptops. But right now you can see the conflicts where not even single, maybe one or two may be using desktops. Most of us are using laptops. So that's how the technology has changed. Because the technology has changed, even the features of the personal computers are also changed. So now you can see in our thing what we have. Even we have web camera, we have so many hardwares are also included. So that's what, if before in personal computers we were not having web camera. If I want to have a camera, then I have to buy separately. So that's how the personal computer systems was used before, some 30 years down the line. But right now most of advanced features is also there. But still if I start giving you an example, the students may not require so high end systems for their projects, many projects, whatever it is. So that's what CPU utilization of how do you utilize. And protection features, it's left to you what anti softwares you use in your personal computers. So everything is there, but we have to keep updating them. That's what about your personal computer. So you can see how the migration of the operating system concepts and features have been advanced as we keep moving on. So that's what in 1950s no softwares were there, and only compilers were there, and resident monitors were there. Resident monitors we would have seen very big, and mini computers and microcomputers were not there in 1950s. So now as with a gap of 10 years or 1 decade, advance in technologies, even the operating system is also getting advanced, and some features have been adopted in operating system. And time sharing, what we are saying, time sharing is feature also introduced in 1960. And still then there were no softwares, and it was only a resident monitors were there in 1960s. So later on, after some days, because as it keeps going, multi-user systems were also started in 1965, around between 1960 to 1970. So then multi-user, many people started using it computers in a mainframes also. So when you come in 1960s also, mini computers started, but without not much high-end softwares. When we come to 1970s, time, even in my mini computers, time sharing was also there. Then microcomputers were also there in 1970s, and network computers were also there. So before maybe 30 years down the line, we were not having something called as internet. If you would have imagined, so if you want to see your results, you would have gone to your schools or colleges to see your results. Right now, how is the thing? Every one of us, even a 10th standard student or even a kindergarten students, everything is being changed. And you can see the results also nowadays. It is coming in the app. The school apps will be there. They'll send their results. So that's how the technology have improved as the days moving on. So that's what 1970s. This is what improvement. Then even small network computers started. Then in 1980s, so distributed system. So distributed system is what? So I cannot say that I have one system. Suppose let us take your anything which something you kept very important in one place, your data. Let me come back. You have kept data in one system, and you don't have network facility, or you don't have any copy. Then whatever work you have done and whatever you have kept in one computer, it will definitely, if something goes wrong, everything will be lost. Same thing. So you would have to do one software. Let us take an example that you have developed some app, and to develop that app you have spent around 3 months, and coding, whatever you have done, documentation, coding, requirement analysis, feasible, all these whatever you have done, even testing, all the work what you have done for related to develop an app is in one system. Suppose by the other person, without his knowledge, he pressed some keys and your app got deleted. So then your 3 months work is lost, and again you have to redo everything. So instead of that, if you would have kept the same whatever app you have developed in other backups or 2 or 3 places, then that's what a distributed system concept says to us. So multiprocessor, earlier before 1980s, your processors was single, means only one processor were there. But a concept of multi-user was started in 1960s only. After 1960s, multi-user means many people can use. But multiprocessor means what? Before 1980s, only you were having systems, but only one processor was there. Means you could have done only one work at one time. So then that's what the multiprocessor that came into 1980s. And in mini computer also there is an advanced improvement in 1980s. So slowly in 1970s only they have started with Unix operating system, and multi-user also started in that. And microcomputers started. There were having something called as a compiler, interactive, multi-user. So then even there also network computers were also started. And in 1990s, along with whatever existing features were there, they added some more features in 1990s for mainframe system, fault tolerant. Means if by mistake, if something unknowingly have pressed, that's what it should not delete everything whatever we have done. So that's the thing. You would have seen small example. Let us take in your Word or anything you say. Once you save your files, keep saving your files, and power goes or you don't have backup, then whatever saved, it will remain because you have saved and it is in a main memory. After you get back your backup, you can open and you can still see whatever you have saved, it will be there, and whatever you have not saved after that, it will not be there. That's what the fault tolerant means to us. That was there in your mainframes. And in mini computer also multiprocessor started. So multiprocessor, before that it was being used in mainframes. Now they have started using in mini computers also multiprocessors, and even in micro computers also they started using a multiprocessor. Now you can see in your laptops you may use so many based on your features. We have a multiprocessor concept. That's what dual boot, dual system. There are so many things which we have in a mini computer and even in a network computers. Though there are no things, now compilers started in the 1990s. But now coming back, just now you can see cloud. As the cloud has come into the market, you can save all your softwares. Suppose let us take back, before, if I want to buy any software, we have to pay any company. Even let us come back for colleges, we have to buy all the softwares, and we are not allowed to have a pirated system. So in that case, for buying one software, it was taking huge. And in that case, so as we have in cloud, so we cannot say that only computer science department will use Java and Java compiler and other people will not. No, not like that. So everyone, even EC students may use, or any other streams also can use. So that's what. Now just take an example. So right now we were using a MATLAB in our college, and before uh, also before 10, maybe 10 years down, or 5 years or 6 years down the line, we have purchased a MATLAB software only. We have paid so much huge amount and we have purchased, and only EC, because requirement was for EC and TC people, and they were using the MATLAB. But as it is increased, because it is a software, it can be used for anyone. So now you can see present scenario, you can see that everyone within a campus you can use. So within a campus you can use means network computers, right? If you have to just connect to that particular MATLAB, then you can start using it. So this is what a migration of operating system concept, and how operating system has changed over the time. Okay, coming back to this parallel systems. Before I move on to a parallel system, I'll just give you an example. Parallel means what? So let us take an example. We have a site and we want to construct a house, and I want my house to be completed within a 6 months. But the contractor, or some people say within 6 months is very difficult because we need so much time and we may take it for 1 year. But client will say no, I want it within a 6 months. Then what the contractor has to do, he should check whether what works can be done parallelly to complete any project within a 6 months. So then he can say that when a foundation is being done, so side by construction of the rods, many other things, parallel things can be done, so that the time can be saved, 6 months time can be saved. That's what a concept of a parallel system is. Similar fashion here in our systems also, in operating system also, we are using something called as a parallel system. Parallel means simultaneously we have to execute 3 or 4 works. So that's what the multiprocessor system with more than one CPU is closely communication. So what is parallel system? Multiprocessor. Multi means what? Many. Processors means CPU. If I have more number of CPUs, I can do my job parallelly, so many work. So let us take now in this example, I am using laptop, one application I am using. Along with that, I am using one more called as a recorder. So I require PPT, I require audio. So what are all these? These are parallelly I am using. All these are required for each of the thing. That's what a parallel system says to us. But all these, if I don't have camera, you cannot see me, and if I don't have audio, you cannot hear my voice. So that's how it is tightly coupled, all these systems. The processor share memory and a clock. Though we are saying that CPU, but still the memory is being shared between all these. Along with that, even clock, the system clock will also be shared. You cannot say that because I have increased my processors, so I will be having different clocks or different memory. Sorry, that cannot be done right now. So the memories can be the place where you have stored all your data will be only one, but that you can fetch back from the memory part, can store it somewhere for any calculation anywhere. So that's the reason we have a processor, and you cannot have a 2 or 3 clocks. There will be only one clock where it will be shared among all these. So communication usually takes place through the shared memory. So the memory can be shared for a different people. That's what the parallel system says to us. So advantages of having a parallel system is increased throughput. Increased throughput means what? The output of your work can be made it faster. That's what I gave you an example initially. So instead of 1 year to complete your civil project, you would have completed within 6 months. That's what the output is. What? Instead of waiting for 1 year for your construction of your house, you have done within the 6 months, and that's what the 6 months you have saved. That's what the increased throughput. Economically, even we can see where though 1 year or 6 months, so the economical increase may not be very high for 6 months or 1 year. Suppose let us take same thing, construction only. So the person, if as you can see day by day the increase in the utilization of so many items when constructing, if you drag it to 1 year, they may raise, or chances of raising is more than coming down. So then definitely your prices will also increase if you consider for 1 year. In the same way, 6 months it will be lesser. That's what economically also we can think the parallel system are working very better. Increased reliability, because we are using so many parallel CPUs, you can rely on the whatever the increased reliability, so something like graceful degradation, fail of soft systems. So because we are increased in a processor, many processors are there simultaneously working, so the failing of one processor cannot make your complete work to come down, but still it can work. Same way how right now as our India has been brought down or locked for 21 days, but still we have to think over what alternative we can do. But this is a precaution for our country only, as Prime Minister told, if you don't lock for 21 days, we'll go back for 21 years back. So instead of that having only 21 days, it's better than going back, right? So then you cannot say complete soft system is failed, but still as a academician we have to conduct some classes. That's how we are doing it through a YouTube. We may use Skype, we may use Zoom. There are so many communication things where we can use. Continuing with the same parallel system, symmetric multiprocessing. So each processor runs an identical copy of the operating system. Many processor can run at once without performance deterioration. That's what I told. We may use, because it's a multiprocessor, so we are using multiprocessing, then the processors will be more still to increase the performance. So most modern operating systems support a symmetric multiprocessing system. So asymmetric multiprocessing systems, what is asymmetric? Each processor is assigned a specific task. Master processor schedules and allocates work to a slave processor. More common in extremely large system. So symmetric and asymmetric is, so asymmetric means a specific task will be allocated for each processor. The master processor will be checking out or scheduling which processor is doing which should do at that particular time, which processor had to execute that part of task, which next processor what it has to do, next processor what it has to do. This scheduling and allocating of the work will be done by a master, and other processor which are acting as a slaves will be performing. That's what the asymmetric multiprocessing is done. More commonly is extremely large system. So asymmetric, this may not be used for a simple things, but if it is very high end where your projects are very high, then only this particular processing can be used. So you can see here asymmetric processing system architecture. So you may have n number of CPUs and we have only one memory, and this memory is shared between so many CPUs because each CPU is given a different task. So it will be doing each CPU, let us take an example, one CPU is doing Java, another CPU will be doing some other program, some other CPU will be doing some other. But who will assign each one? Master, as I discussed, master one will be deciding and scheduling at what time this one should be working, what time at this time should be working. Similarly, you can see right now what if all staff 6 staff are taking for your semester, all 6 staff started using Skype or Zoom at that particular time. How about the students? And it may not be possible. So in that case, each one will be using a separate time slots. Similar like your timetable. What we are doing, each time, each staff will be taking a different time schedules for a different classes, different subjects. So that's what. But same for same semester, we are teaching for different subjects. So next we move on to a real-time systems. What are real-time systems? We can see there are so many huge number of real-time system, often used as a control device. It may be used for controlling a device in a dedicated application such as controlling scientific experiments, medical imaging system, industrial control system, and some display system. So there are huge number of real-time systems. You can see scientific experiments. So now we say research. So now coronavirus, we are still don't know what is the antibiotic for that. The medical field people are trying out what are the thing, and we know that China people have given us because there that was a place where huge number of started, and they've given a document saying that what are the things, how it is coming, what. That's what the real-time systems, imaging systems are working. And scientific experiments. So now research center, there are so many research centers, research scholars are there. To work with them, they may require so many real-time systems. Industry control system, you can see there are so many huge industry control systems are available, and some display systems. So now initially, how was our TV display system? If you want to speak about display system, only displaying was there. You don't have any control over your channels. Before maybe 40 years down the line, a TV was there. And how was a TV? TV was very domed TV, and it was not flat, and whatever the channels, only government was having the channels, DD channels, you would have known. So but as technology has increased, some years down the line, we were having a different channels were there, and we can just scroll down or switch to one channel to another channel. That's all we were able to do. But right now you can see the technology, how it is improved, and when you want to shift from that also, your remote also should support that particular thing. That's what your support for your system. So nowadays you can see, because of this fiber and high-end communication systems have increased, your TV you can control as well as you can see what you want to view. So that's what the display systems have been increased. So one more display system you can see in your railway station, in your bus station, or in your airports, where everything will be displayed. What time this train is coming, this flight is coming, what is the name, what time it is arriving, what time it is departing. All these details will be there. That is what is doing. Only displaying part is been working. That's also real time. So well-defined fixed time constraints. So that's what these things, if we consider railway. So you can see wherever there is a monitors, they are all fixed. If one monitor is displaying the same, the other also is displaying the same. So that's what well defined. And fixed time constraints. So I cannot say that I'll display whatever coming 1 week trains now. It's not feasible also. Then fixed time. So today now it is what time next train is coming, next. Only for one particular hours you can see the scrolling will be going on. That's what the real system. And again it changes in real system what type of things you are using. So hard real time system, secondary storage limited or absent, data stored in short term memory or read only memory. So that's what your display screens in the railway stations, they don't have high end memories. Maybe it is not there only. So that's how the memory is also there. Even if it is there, then read only memories will be there. Means very short memories. In the same way, now take your smartwatches. What is the size of your memory? What you want? You cannot store high end, but small things you can store. In the same way, you can see in your market right now, there is something called as a smart band. What the smart band is doing, there is a small memory where it will be keeping track. There will be sensors where it will keep track of your steps, how much you have walked, how much you have walked steps, how much you have slept, and you can see all this. But how is the memory? Memory is very small. So that's what a real system like this. A huge number of list of examples are there in where we are right now using a real-time system. Conflicts with time sharing system, not supported by a general purpose operating system. So it depends upon how we are sharing a particular thing. Next, moving on to a soft real-time systems, limited utility in industrial control or robotics, useful in application multimedia, virtual reality, requiring advanced operating system features. So that's how. So if we come back to our supercomputers, so as you can see right now, because most of the countries are not getting a solutions for a coronavirus. So now you can see in the thing, the America people have started finding out what is a solution for a coronavirus. Then they have approached, or they are moving towards to calculation. Then when they are calculating huge data, then they use a supercomputers. So that's how the soft time real systems are also being used. So this is about hardware, software of a real system using in the market. So that's about a real time system. Next we move on to a distributed system. So what is distributed? Meaning of distributed means keeping a more number of copies in different systems. That's what is called as a distributed system. Because if something goes wrong in one system, wherever you have a copy, you can take back and work. So that's what a distributed system is. So let us take an example. Suppose if you have done mini project and you have an exam tomorrow, then how will you be prepared? So one copy of your project would be in CD, one copy of project will be in your pen drive, one will be in your laptop. Now what you have done, your projects are distributed in 3 places. One in your pen drive, one in CD, one in a processor. Why? Because you don't want to take risk for your exam, because you have to demonstrate your project. If something goes wrong with your laptop, you can still have a copy in your pen drive. Still, if you forgot bringing a pen drive, even still you have a CD. There are so many other options, alternative you think for your small exam. Similarly, think now banking systems are using every bank are using apps. So if my bank account is showing me so much balance, it should show. And tomorrow if my server is not working, I cannot say because my server is not working and your balance I cannot. It's not like that, right? So if one server is not working, it should be in a stage where it should come back very fast. So that's what a distributed system is doing, the concept of a distributed system. Loosely coupled system, each processor has its own local memory. As you know, each one will be having its own memory. A processor communicate with one another through various communication lines such as high speed buses or telephone lines. So loosely coupled, so we have a processor for each of the systems. Let us take some example where you have a 3 distributed and you made it as 3 distributed system, and to communicate between all these you may use a high speed buses or telephone lines. So right now you can see in our labs what we have a LAN connection as well as Wi-Fi connection. If you off the Wi-Fi connection, still you can share your data through LAN. If you have kept your data in one of the system and you want to install the software in most of the thing, then you can use a LAN connection and you can just install in a different system. That's what the distributed system can be done. So advantages of distributed system: resource sharing, you can share the resources, computation speed up, loading share. Along with that, distributed, because the work is distributed among so many people, the load will also be come down. Reliability, how much we can rely, because distributed system, if something goes wrong in one system, other systems are there for a backup. So that's a thing where reliability comes. And communication, because we are using so many high speed buses, definitely the communication is also improved. We see some more features of distributed system. Network operating system, as I told, LAN, WAN, so local area network within particular lab, and WAN, now that's what I told, WAN here without wireless. So now you can use, we have a BMSIT college internet facility, but each one should have a authentication. So that's what you can use within the LAN or you can use in a WAN also. You can use in your mobiles where you don't require any cables. So that's how it is working. So that's how the network operating system provide file sharing. You can send your files, provide communication scheme, runs independently from one computer on the another network. And distributed operating system, the operating system is distributed, less autonomy between computers, gives the impression there in a single operating system controlling the network. So these are some of the features of distributed operating system. So now let me stop now and